All right, so let's go ahead and get started. So this is your practice exam. And let's see, Andrew, teaching, intro, exam 1. And this is your actual exam. So when you get to your actual exam, it's going to look a bit longer. Don't worry about that, because a lot of those questions are, I had a tendency to give you a lot more space on the actual exam to do your problems. So don't worry about the actual length of the exam. Like this last page, one point, that's something to ignore. Here, it's a lot more compressed. Also notice that there's 105 points on the exam, but your grade, so on the practice exam and on the exam itself, but your grade will be out of 100. That means that there's a 5-point buffer built in, sort of an automatic 5-point curve, if you will. It works out that way. Something less than 5-point curve automatically, but it's kind of built in that there's 5 points of extra credit just baked in. So first and foremost, the most important thing you should note is that you should read this page, right? On there, I will have a list of functions like this, just so you basically have reference if you forgot to write them down in your notes or something like that. Okay, and then they're the ones that I feel like you should really know them. So the points do roughly correspond to how difficult the questions are. So 10-point questions are harder than the 5-point questions, okay, which are generally the coding ones. The amount of space that I leave you for a problem does not correspond to the amount of difficulty, right? Just because it takes up an entire page doesn't mean you have to spend the entire page coding. In 2168 is actually kind of terrible for those students. So that's the class after this. They have an exam tomorrow, and they have one question on their exam where I've given them an entire page, and if they're clever, they can do it in one line of code. Okay, this gets even worse in my next exams where I do this for multiple problems, and they can complete entire pages in 4 lines of code if they're clever about it and understand what they're doing. So it does not necessarily So why do I give you so much white space? Well, because I know how much you like to erase stuff and how much you like to cross stuff out sometimes, right? So it's and it's also to give you extra area to work, not have to worry about trying to attach, any extra sheets of paper. That's fine. You are allowed to clarify any answer you give. Okay, you are allowed to add clarification, right? And I've seen people and there's been cases where people have turned wrong answers into right answers by clarifying their assumptions, right? They're like, well, I'm assuming it works this way, right? Like, okay, so for this problem, I'm assuming that that the strings they enter are at least 3 characters long. And, that's a perfect clarification for the answer, and then it's fine, right? You're also allowed to ask for clarification. You're allowed to ask me or the TAs how we should interpret this question. This one's big for the expression ones. Things are never really as complicated as they appear, especially the math. Also read this page on the actual exam. There's a hint there. Hint will pretty much be worth 6 points. It's nice. So never leave a question blank, especially if you don't know the answer. I'm a big believer in partial credit. My grading policy is that if you've got it all wrong, but you've got some stuff in there right, I try to give you as many points as possible. And then if you've got like a 10-point question and you get a few things wrong on that, but it's mostly right, you're only going to lose a couple points, right? So if it's mostly right, I look at a couple of syntactical errors. That being said, the syntactical error, it doesn't have to be 100% syntactically correct. In other words, making a syntactical error that would like forgetting a semicolon, that's going to be like a 1-point mistake. It's not going to be a 10-point mistake, right? I'm not going to say your program won't run because it's missing a semicolon. I'm not that guy. Okay, and then finally, if you give me something really original or interesting, or I didn't think of, or a solution I didn't even think of, extra credit. So, all right. So this one is referred to the first lecture. So your first page will be like this. These are kind of like a nice built-in buffer points if you remember your first lecture. So true or false? Computer science is the study of computers. False. Right. That was an easy one. So what is computer science? If we're going to say it's the study of something. Algorithms. The computer science is the study of algorithms. So there's a lot of definitions for computer science, and we quibble over them. And you ask a bunch of computer scientists, they'll argue. If you ask 5 computer scientists, they'll give you 10 different answers. But if you tell them that I think computer science is the study of algorithms, they'll nod their head and go, "Yeah, okay, I guess so." right? Right. It's a definition that we can go, well, it's not fully complete, but we can all agree on it. Okay, so Alan Turing is considered to be the first programmer. True or false? False. Who is considered to be the first programmer? Ada Lovelace. Ada, the Countess of Lovelace, and it gives you the second question. Who is Ada Lovelace, and why is she an important figure? She was the first programmer. She's often considered to be the first programmer. Okay, so you might, if you're clever and you can't answer the last question on the first page on the actual exam, look at the other questions. They might be able to help you out. So, all right. So this is another page where basically it's almost identical on. So this page is almost identical on the actual exam. The only thing that's different is the numbers. Okay. So what would each of these expressions evaluate to in Java? So 2 times 3 is, so here we go left to right, okay? So it's all about remembering PEMDAS. So 2 times 3 is 6, divided by 6 is 1, right? 1 times 100 is 100, so that's some easy math there. The math might involve some actual, the math, once we get to really tough numbers like this, you'll find that actually it shouldn't really be that bad. All right, 1 mod 2 plus 3 mod 2. So, what's the remainder of 1 after being divided by 2? It's 1. And the remainder of 1 after being divided by 2, the remainder, right? The quotient would be 0 here. 1 divided by 2. So mod means the remainder. After being divided by 2, it's 1 over here. 3 mod 2 is 1. So it's 1 plus 1. It's equal to 2. Okay. -1 plus negative 10.5. Just remembering that basically, just this one just tests, did you remember that these converts, right? That you can add, first off, remembering that you can add these things, and that basically that the -1 gets converted to -1.0. In other words, it works exactly like the way you'd think it would, which is 11.5. A lot of times I think of like just leaving this part out on the test. But most students, most students will miss maybe it's common for a student to miss 1 or 2 of these, which is like, okay, so if students get like 8 out of 10, that's fine. But then students still, like, there's a couple of students in the class who will miss like 6 of them, even though they do well on everything else, and that's why I keep this. So, don't take this for granted. 4 plus 5 minus 3 times 2, right? So here we do the multiplication first. 3 times 2 is 6. 4 plus 5 is 9, so 9 minus 6 is 3. I don't even remember these questions because I wrote this practice exam so long ago, but you can check these. That's another thing about these. These are Java expressions, so you could copy and, put them over here in a system.out.println and test them out. Oh, why does it give me an error? Because because the PDF encodes differently. Notice that that's a star right over there in the middle, and if you actually type an asterisk, it comes out with that. So that's just to note that basically sometimes when it renders a bit weird. So you can check your answers pretty easily with these questions. All right, 0 times some god-awful number, right? Well, 0 times anything is what? It's 0. So 0 minus 1.0 is negative 1.0, right? So a lot of times you'll see stuff that gets simplified like that. This one's an easy one. 2 times 4 minus 20. That's just simply 8 minus 20. So negative 12 there. Then here we get into the more interesting ones, okay? 7 divided by 3 plus 2 times 3. All right, so 7 divided by 3, remember with integer division, you have to throw out the remainders. So 3 goes into 7 twice, right? Just go back to 4th grade to remember this stuff. So 7 divided by 3 is 2. Plus, okay, I can remember 2 on there. 2 times 3 is 6, so 2 plus 6 is 8. 4 mod 2 times 3. So 4 mod 2 is 0 because, again, it's the remainder after the remainder of any number divided by 2 is 0. So 4 mod 2 gives you 0 times, any whatever is going to give you 0, so that's fine. Some big number divided by an even bigger number. That's 0 as well. Because, remember, this is some integer divided by some integer. This big number can't go into this other number, so it's the answer would be, 0 remainder 52,482. So the answer is 0 over there. And this one's just a reminder. You can put stuff in scientific notation in Java just fine. 10.0 E1, what's that mean? Well, the E represents 10, and this is 10 to the first, right? So this is 10 times 10 to the first. Do you all remember scientific notation from chemistry? This is exactly the same way. So this number is 100. This one won't actually be on the test, but you should remember that it's there, because sometimes when the numbers get really big, then Java just really has no point but to represent them in scientific notation. All right. So another thing that's going to be on this exam. Okay. Almost exactly. So these are all worth. So those were all worth 1 point. These are all worth 1 point. You can use a problem, and it's up to you whether you want to solve these things first, or you want to skip over to the programming section where the bulk of the points are worth. Right. The bulk of the points are worth in section 5. And then a lot more in the So after this point, the questions start being worth more, because these are fairly easy to do, but at the same time, I want to ask a couple of them because I don't want you to make a stupid mistake on one of them and then lose 15 points, right? Right? So, all right. And again, these typically go from easy to hard. Okay, true or something else, right? True or something else. Well, or means only one of these things has to be true for the whole thing to be true. So I don't even have to look at this 3 equal 2, which is false anyway. But I don't even have to evaluate that. True or anything else, that means the entire thing is true. So I'm done. Right, true. Not false. That flips that to true. Those here where there. Sometimes I give you stuff like that to remind you what the rules are, just to give you a slight nudge, a bit of a hint, to make sure that you get the rest of the stuff. Okay. All right. So the opposite of 4 less than 2. So 4 is less than 2. That is false. But not false would be true. So this side is true. And 3 less than 10. That's also true. So true and true, this thing is true. This one's a bit trickier. So 32 divided by 8 not equal to 32.0 divided by 8. Because this is something we haven't had to check yet, and your instincts might be going yes or no. So let's reduce this to an easier question, right? Because right now this not equal is going to actually drive us crazy right now. Okay? Right now let's look at, is 32 divided by 8 equal to 32.0 divided by 8? Okay? So let's look at that. So we've got on this side, 32 divided by 8 is 4. And 32.0 divided by 8 will give us 4.0. So now the question is 4 equal to 4.0? So, this is one thing. So, if a lot of students will instinctively say those are not equal, right? But when we're dealing with doubles, remember, and an integer on one side, it can't compare them directly. So what does it have to do? It's got to convert them. So let's go ahead and look at that. 4 equal to 4.0. That's going to come out as true because we have to convert the 4 in order to compare it to 4.0. Now this one is, again, this is one of those ones where I say it's going to be harder on the exam than actually it's going to be harder on the practice than actually on the exam, because this is one of those really nasty trick questions, because this thing over here is, in order to compare the integer to the double, we have to convert it. Just like if you were going to add an integer in a double, we'd have to convert them. So, okay, but you can't just put down true, of course, though, because you got a not equal there. So the answer was false. Right, so that one's one of those ones where it's particularly nasty. And here I put in I always put in the parentheticals when I mix ands and ors. I always put the parentheses around stuff because there is a precedence for ands and ors, but I wanted to make it easy for you guys, and also to enforce the fact that basically if you're mixing ands and ors, you should always use parentheses so you know what you mean. Okay. So first, let's go ahead and look at this. So there's this whole expression over here, and that looks kind of terrible, right? So let's go ahead and just knock this out one piece at a time. So this parenthesis over here says true or something that resolves to false. So that side is true. This side is not true or false or true. So this resolved for true. But then it's a false over here, right? So it's a true inside, but then the not flips it to a false. So we've got true over here compared to an and false, which means that the entire thing is false, except that we've got a not on the outside now, which flips everything to true. Okay, now I can do this in my head. I highly recommend you don't. Okay? In fact, the way I recommend you do this, okay, is to, so I've switched that over to there. So tell me if I forget to switch it back. Let's see, that was not, and then I had a second parenthesis, true or something else it didn't really matter there. And then and. So on the exam, by the way, if you can't draw an ampersand, because I certainly can't, you are more than welcome to write and in all caps, okay? That's perfectly fine for me. Let's go ahead. So we've got true and something else, and not true, not false or true. Okay, so what we do is that we just simply cross stuff out as you evaluate it, okay? That's what we do. So this expression is true or something. It was 3 less than 2? Yeah. So I'll cross it out. I'll replace it with true, okay? So now it's easier to read, kind of. But I cross it. Then I got not true. I've got false false or true. So I cross that out. That should resolve to true. And then I have to flip. So now I've got not true. So I cross this out and got false. Right? So just basically cross it out as you go along. So now we've got true and false, which resolves to false over here. And not false resolves to true. So basically just simplify it, essentially. Cross it out as you work on it. It's your paper. You're allowed to do whatever you want to get to do what you need. Bring highlighters if you have to. Okay? The dry erase marker, the pen, the pencil, some paper, some highlighters, those are the best tools of a programmer, not a computer. The computer is just to get you learning how to program and learning how to do algorithms. Once you get started, though, the ability to think, the ability to split stuff up, the ability to take stuff and split it up into discrete little parts that you can solve individually, that's what makes a programmer a programmer. Surprisingly, it's not the ability to program. It's the ability to solve problems. Okay, so this one I apologize because the exam will look like this, and these questions do look slightly ambiguous as to what I want. So I'll show you exactly what I want on the board. So let's write a if statement that checks if int x is a multiple of int y. So for these questions, I tell you that you can assume that the variables I talk about already exist, so you don't have to declare them. all I care about for these questions is you writing an if statement, okay? And then I don't really care about what's in the body of the if statement. Remember, the body's that stuff, the stuff inside. So let's go ahead and write a statement that checks if it's a multiple of x or y. Okay. So what does that look like? That will look like if x mod y, right? So if the remainder of x divided by y is equal to 0, that means that x, so that's how you can check if numbers are multiples of each other, right? Because remember, when we were dividing by 2, when we were doing a number mod 2 to check if it was even or odd, we were asking, is x an, right? So if I do x mod 2 equals 0, this is a Boolean statement that returns true if x is even, which is another way of saying if x is divisible by 2, which is another way of saying if x is a multiple of 2, right? There's a lot of congruent statements in mathematics. So here we're just checking if x, and then I like to put curly braces. But again, this is all I care about for these kinds of questions. Yes? If x is a multiple of y, y mod x, that would mean that, so that would be asking if x is cleanly divisible. So this asks if x is cleanly divisible by y. Y mod x would be if y is cleanly divisible by x. I'm pretty sure I have it right. But now you've got me paranoid. No, so asking if, so let's do, is 15 a multiple of 4? 15 mod 4, that won't return true. That won't be true. But 15 mod 5, that would evaluate to true. So that would check if 15 is a multiple of 5. Okay. So a lot of times if you need to double check that, you can plug the numbers in. However, that would have given you at least half credit if you flip the variables. Okay? So I'm a big believer in half credit. If you realize, oh, the way I need to solve this is mod, and then that's either 2 or 3 points, even if you don't get the whole thing right. So this one's a bit of a trickier one. Write an if statement that checks if either x or y is even and the other one is odd. So we have to check basically one of two things. X is even and y is odd. Or x is odd and y is even. This one's a bit of a, so let me just flip it onto the board for a second. And I'll go ahead and type this up on here because that's easier for people to see. Okay. So write an if statement that checks if either int x or int y is even and the other one is odd. Okay. So there's a couple ways to do this. The easiest way I found is if x mod 2 equals 0 and so if x is even and y mod 2 is equal to 0. Y is odd. That's one condition. Or the other possibility, and notice how I put parentheses around each of those, just to make sure it evaluates in the right order. Or the other possibility is y mod 2 is even. Oh, wait, I didn't do it right over there. I checked if both were even over there, right? So y is odd. Y mod 2 is even. And x mod 2 is odd. So we do check to make sure that basically that you are, those kind of mistakes, those are easy to make during like a stressful situation during an exam. Oh, and write int x is equal to 3, int y is equal to 4. This is just simply to get it to stop screaming at me that x and y don't exist. Okay. All right, so iterative statements. So what is the output of this code, right? So now you could probably just run this. So did you have a question?
Yeah, I have a question about that. So you just assume that the OR is inclusive?
Or is inclusive. I mean, or is always inclusive. Or is inclusive.
Yeah, I mean, but like the English word or
question. Oh.
Like in English,
yeah, I know exactly what you mean, but that's why I tried to clarify it with the other one is odd expression, so they can't both be even, right? Right? So yeah, I get what you're saying, but that's one of those cases where basically if you made an argument, right, and you wrote down your argument on there, like assuming or is inclusive for that, then I'd have to give you some points because it would be because you're making an argument and you're understanding the meaning of or, which is kind of also an important point. All right, so these are ones, again, that you can just easily check. What is the output of this code? Int I is equal to 0, I is less than 10, I plus plus. So the values for I are going to be 0 up to, but not include, 10, right? So it's going to be the values 0 through 9. All right, so let's count them. We'll count them to see what needs to get printed out. And it says if I mod 3 is equal to 1, in other words, if I divide by 3 and there's a remainder of 1, print out I. So 0 divided by 3, that does not give me a remainder of 1. 1 divided by 3, that gives me a remainder of 1. So I'll print out 1. 2 divided by 3 gives me a remainder of 2. 3 gives me a remainder of 0. 4 by 3 gives me a remainder of 1. Right? So kind of repeat. So that's the interesting thing about modulus, that it repeats. It starts 0, 1, 2, 0, 1, 2, 0, 1, 2 for the remainder, right? Because of just the way that, that if we were modding by 3, then every third number is going to be evenly divisible, so we start over. So the answer should be 1, 3, 7. Sorry, 4, 1. 1, 4, 7 for this one. All right. So convert the following while loop into a for loop. So here int I is equal to 2, so that's your initialization statement for the loop. This is the I is greater than 0. I is less than or equal to 1. Sorry, I is minus equals 1. So this one is pretty easy to convert. For int I, let's go ahead and, oops, I just dragged it onto the, all right, how do I get you over? There we go. Keyboard shortcuts for the win. All right, for int I is equal to 2, while I is greater than 0, I minus equals 1. System.out.println bang. So that's how you can convert that while loop into a for loop, right? Yes. Yeah, that would have also been an acceptable answer. I minus minus. For some of these, there's multiple correct ways to do this. For instance, had you done this, this is technically more correct because I is now outside of the loop just like the I over there is, right? So there's a lot of correct ways to do this. And so long as they all function the same way, that's what I really care about. Okay. What's wrong with this loop? I is equal to 0, I is less than 10. Print out I. It never ends. Because, right, while I is equal to 0, while 0 is less than 10, print out 0. While 0 is less than 10, print out 0. While 0 is less than 10, right? It needs the I++ operator in there to increment it. All right. So this one is write a nested for loop that prints out the following: 10, 8, 6, 4, 8, 6, 4, 2, 6, 4, 2, 4, 2, 2. So what is this doing? This is printing out the number. So first off, we need a nested for loop here to do this. It's not too bad actually to do a nested for loop. So first off, since this isn't taking in a variable number of lines over here, this just requires us to print out, just starting at 10. So that makes it easy. So for int I is equal to, well, actually, first we want to figure out the number of lines, right? The number of lines is the first thing we need to figure out. How many lines are there? 5. 5 lines. So int I is equal to 0. I is less than 5. You can also do less than or equal to 5 and start at 1 instead, right? Either of those are functionally equivalent in this case. I plus plus. Okay. So let's see. We're going from 10 and we're counting. So we start at 10, right? The numbers start at 10 and they go down, but they don't include. So we start at 10 on this line, then we start at 8, then we start at 6, then we start at 4, then we start at 2. Okay? So for int j is equal to 10, right? All right, so int j is equal to 10. J is less than, j is greater than, let's say 0, right? Because we're going down and we're not including 0. And we're subtracting 2 each time. I minus equals 2. Not I minus, common mistake there, right? I'm subtracting I there, so j. So maybe I should give them a better number, right? Num, the number starts at 10, it counts down, right? And I'm counting down at each time, and obviously I should just do system.print line over here, and print out, not print line, I want print because I want to print them all in the same space. So space plus num over here. Mind you, you don't want to waste too much time with this one, so come back to it if it's giving you a lot of trouble, because this one's 4 points, and there's some 10 pointers on this one. Okay? So we've got that printing out, and then I want to print out each row, but I look at this, and I read it over, and it's going to do 5 lines, and every single line is going to do 10, 8, 6, 4, 2, if I read this correctly, right? Every single line is going to do 10, 8, 6, 4, 2, because each line, because the inner loop doesn't change between each line. Does that make sense? In order to change what the inner loop does, each line, I have to use I somewhere in order to change it, right? So we want to start, and what changes between each line? Well, we're subtracting 2 each time. Really what changes is the number, and then we stop once we get to 0, right? So really what changes each line is the number I start at. That controls how many numbers are going to be printed out. So in that case, I want to subtract I. That would start me at 9, then 8, then 7, then 6. Really, I should do I minus 2, or I times 2 there. So now it will be 8, 6, 4, 2, and then nothing. So actually, starting at 0 over here was actually kind of easier, because now that should work. So now I subtract 10 minus 0, 10 minus 2, 10 minus 4, 10 minus 6, 10 minus 8, and then we're done. So this part on the actual exam got moved into the programming part. So I moved that over into the programming part, and it's a 10-blank question with if you can't figure it out, there's a there's an alternative problem you can solve for half credit, like a simpler version for half credit. So this is more, but this question is going to be there. Notice that it is 6 points. What is the output of this loop? So you're going to have something that resembles a heck of a lot like this. Int I is, so here I'm asking you to, here's a nested loop that prints out a pattern. What does it print out? Int I is equal to 0, I is less than 3, I plus plus. J is equal to 0, J is less than or equal to I, J plus plus. So we've got a 0, 0, we've got a less than and a less than or equal to. So we kind of need to just track these things to be able to figure that out. So, so let's go ahead and, again, it's easiest to see when I'm doing this. So let's go ahead and just create some comments over here to give us some space. So the way to solve this is to create an I, and then to create a J over here, and then just figure out what your output is from there. Okay, so I is equal to 0, so then we go into this loop, J is equal to 0. Okay, is J less than or equal to I? Yes, it is. So print out I plus J at 0, and then print out a space. Okay, now we go and increment I. Then we go into the inner loop. J is created, it's less than or equal to I. Is 0 less than or equal to 1 at this point? Oh, sorry, I skipped incrementing J. Sorry, let me go back for a second. So we were here with 0, 0. We printed out I plus J. Then we incremented J to 1. J was no longer less than or equal to I. So we were done with the inner loop. We go back up. We increment I. Then we create J again. And now we ask, is J less than or equal to I? It is. So we do I plus J, space, then we increment J. Whoops. We increment J. Is J less than or equal to I? It is. So I add them together, add a space, increment J. J is now bigger than I, so we're done with the inner loop. We go to a new line, and then we increment I. Is I less than 3? It is. So we go into the inner loop. J is equal to 0. So now so 0 is less than 2. So we print out I plus J, increment J to 1. So then we print out I, so they're less than each other, so we do I plus J. So we can kind of see what the pattern is now. So now that 3 is bigger than 2, so we increment I. I is bigger than, I is no longer less than I, so the answer should be 0, 1, 2, 2, 3, 4. Is that what other people got? Awesome. All right. So here's one. What are the values of x, y, and z after the following statements? And then, yep. So there's a lot of questions like this where I ask you to trace the code and figure out the variables. So x, y, and z after the following statements. X is 7, 8 is y, negative 5 is z. So let's go ahead and actually do these on the board. So if you're following along, then we see that I'll just simply write them down. So x is 7, y is 8, z negative 5. Okay, so first line is x is equal to x plus 1. So that means we add 1 to x and we store it in x. So x is 8. The second line is y is equal to x plus y plus z. So y is, so we store 8 plus negative 5, which is 11, in y. Z plus plus, which is the only really tricky part of this one. So incrementing negative 5 brings it to negative 4. Right? Not negative 6. Okay. So now, what is the output of so this one, second one, what is the output of annoy when 5342 is called. So that means we copy 5 into A, 3 into B, 4 into C, 2 into D. Remember, it's positional. So the first thing always goes to the first variable. Doesn't matter even if there was a variable A over here. It wouldn't get. So if we had a variable that said A is equal to 2, right, up here, and then we passed in 534A, the A over here wouldn't be 2. D would be 2 because you can name because the variables can get all mixed up. So first, let's see. Is A greater than B? Is 5 greater than 3? Yes, it is. Is 5 less than or equal to 4? No, it is not. This is an AND statement, so that doesn't execute, so we go to else if. Is D greater than C? Is 2 greater than 4? No, it's not, but it's an OR, so we check the other side. Is 2 less than 3? Yes, it is. So it was false or true, so the whole thing is true, so we print out green. So now we ask 2, 3, what do we do if 2, 3, 4, 5 is called? Well, past 2, 3, 4, 5. Is 2 greater than 3? No. So we go down to the next one because that's an AND, so we can skip the rest. Is 5 greater than 4? Well, it is, so we print out green again. All right. So this is one I actually removed from the test, but it's actually fairly useful. So what is the output of the following program, which is foo, bar, baz? So we've got foo, then we've got bar, which calls foo, prints out bar, and calls baz. And baz also calls foo. So this one is just a matter of following along. So let's go ahead. So the answer here should be, so the first call is to foo. Foo just prints out foo, so that's our first line. Okay. Next is a call to bar, which calls foo, which prints out foo, then bar, and then bar calls baz, which prints out baz, and calls foo, which prints out foo. Then baz, we call baz again in main, which calls baz and prints out foo. All right. The more interesting question is, if we change baz to the in the above to the following example, what happens? Sorry, if we change baz up here to instead of doing baz and foo, it does baz, foo, bar. What happens? It doesn't stop. Yeah, it just keeps going on. It actually doesn't go on for forever. You get something called a Stack Overflow error because you do too many method calls, but it would, in theory, go on forever because what you've got going on is that bar calls, once you make that change, baz calls bar, and bar calls baz, and baz calls bar, and baz calls bar, and baz calls bar, and bar calls baz, and so on and so forth. It just goes on forever. Right? So here, if we make that change, it would go on forever. Okay. All right. So this one is a classic example of what we love to do on exams. Confundus 468, and then we've got int y x z up here, and then we've got z x y. So the only way you can really do that is by making sure you've got the right, got everything that you're keeping track. So y is 4, x is 6, and z is 8. So we increment x to 7 with the first line, and then we say y is equal to y minus x plus z. So we say that y is equal to 4 minus 7, so that's -3, plus z, which was 8, so it's positive 5. So y is now 5, so we've got 5, 7, 8 here. And then the print line is z first, which is 8, x, which is 7, and y, which is 5. Does that line up with what everybody else got? Okay, because I just did that one in my head, so. No. All right. So here we go. Right. So this one's called each character, which returns a new string. So here we want to complete a method called each character, which returns a new string by separating each character with a comma and a space. Okay? So hello becomes HELLO, but notice on the end, it doesn't follow we don't have a comma on the end. It's a fence posting problem, right? Then you've got so 1, 2, I have the exclamation point just to show you that basically, a character is a character. And then A, if we print out A, it will just print out A. So let's go ahead and write this method. Shoop. All right. So first off, we need to return something. So I'll go ahead and create a string output equal to the empty string, and that's going to be my answer, and I'm just going to add stuff to it using concatenation to create my correct answer. All right. So here, for right now, you might recognize the key here is to look at this and recognize the fence posting problem. But the other key is to not care for your first draft of the solution. Leave yourself some space to solve the fence posting part, and just don't worry about it yet, right? Does that make sense? We recognize that I don't want a comma space after that, but because I do stuff based on partial credit, that basically a mostly working solution is good, and then once the mostly working solution is there, I can modify it so that I can change it. So here, right now I'll print out every single character. So for int I is equal to 0, I is less than or equal to str.length to get the length of the string, I++. So here I remember from the Pig Latin problem and other stuff that how to get every character in the string, and counting the number of vowels. What I had to do was to get each character, I would do character C is equal to str.char@I. So we get the ith character. Okay, and if I was just printing it out and not returning a string, it would be like this: system.out.println C plus comma and a space right after there, right? That makes sense? But we know that we're not outputting it. We're concatenating. We're adding it to the output. So we would say output is equal to what's currently in the output, and then we want to glue the character to it plus a comma and a space. Right? Make sense? All we're doing is just gluing that to the output, and then we're returning it. So that will return. So if we got hello, it will return HELLO, but the last O after it will have a space, have a comma and a space. That's most of the credit. That'd be 7 out of 10 points right out there. So but let's go ahead and get our full 10 points. Right? So the last letter is the problem. So why don't we alter our algorithm so that the last character doesn't get printed out? Okay? We're going to alter our method so that the last character doesn't get printed out. So we just subtract 1 so the last character is excluded from this range. And then what we'll do is, rather than dealing with the whole issue of trying to figure out anything fancy to do, we're just going to directly print out the last character. We're not going to print out the last character. We're just going to directly add it. So output is equal to output plus str.char@, and then I need whatever the last character is at, And that would be str.length minus 1. Right? Because here, remember, with the less than sign, I'm going up to, but not including the last character, which is at the length of the string minus 1. Right? Because remember, hello is size 5, so it's through the indices 0 through 4. Right? So this would go from 0 to 3, and then it would slap on index 4 on the end. So that one is a working solution. Full 10 points there. Okay. Other ones to do. Isn't this okay? Write a new method called sum of threes, which returns the sum of the first n positive integers that are divisible by 3. If n is less than or equal to 0, return 0. So this is a running sum problem. So 3 will return the integer 18 because we calculate 3 plus 6 plus 9 is equal to 18. 5 will return 45 because we're going to sum up 3 plus 6 plus 9 plus 12 plus 15, 45. So let's go ahead and solve this as well. Again, the reason I'm not solving on the board is because this room doesn't... Most of the time I would solve these on the board and handwrite them, but the board just doesn't work here or the position of the desk and my webcam and the board just doesn't work for that. So this one is one where we have to do a running sum. Int sum is equal to 0. Return sum, and what we're doing is that we're adding the 3's to it. And this one's not too bad. We want to add together the first n multiples of 3. So int I is equal to 1. I is less than or equal to n I plus plus. And what's clever about doing it this way is that the condition that if we input a negative number or a 0 as n, well, if it's a negative number, this will never be true, so the loop won't run. And if we put in 0, the loop won't ever be true. So now we just do sum is equal to, so now we have to calculate the first multiple of it. So int molt is equal to, I want the first multiple of 3. The first multiple of 3 would be 1 times 3, so that would be 3. So I times 3 would give me the ith multiple of 3. And now I just have to add it to my sum. Sum is equal to sum plus the multiple of 3. And return the sum. So it's actually not too much code there. All right, what else do I have on the exam? In the main function provided, you write a program that repeatedly asks the user to enter an integer. The program keeps asking the user to enter the number 13. Once 13 is entered, it sums all the numbers entered, including the 13. And you can assume the user follows direction. This one's fairly straightforward. I don't really feel the need to go over it because you can also check it as you check your program by writing it. Okay. Rather, so I'm going to actually skip this one because it is kind of trivial. And I'm going to go over, and I'm going to point your direction to the fact that I attached a bunch of extra questions over here that have extra practice over here. So write a nested loop that prints out the following: 10, 8, 6, 2, 0, right? So it's a lot like the one we did that was given as a problem, only now it includes 0. Then this one, except that what gets printed out, we always start with 10, and it's the back end that changes, right? So try solving these if you're having trouble. Project Euler problem 1, which is the one that you did in class, right? Let's go ahead and look at some other ones. I wanted to make sure that I went over some pertinent ones. So write a method that prints out the first n powers of 2. This is a question from a previous exam that I've done, so that's actually a good question. Printing out the first n powers of 2. That's a lot like this one over here, where we're printing out the sum of the first multiples of n, first n multiples of n. But instead here, instead of doing multiples, we would just be doing the power of 2. We would be doing math.pow 2 to the ith power. Let's look at this one. Write a method that takes in an integer and returns how many digits it has. Didn't we do that one for homework? So I've listed it there because that seems to be, I've listed it twice now, so that seems to be important. So let's go ahead and write that one. Public static int num digits int n. So how many digits does it have? So int n is equal to 0. So that's it starts out with 0 digits. And then num. So while n is greater than, so this is even easier with a while loop here. While n is greater than 0, num plus plus to get myself the nth to num plus plus to get the to say, oh, it's still got more and more digit. So I increase the number of digits that I've seen by 1, and then I do n is equal to n divided by 10 to get rid of the last digit, right? And then I would just return num. Now the reason I like this one is because I can and I will turn it into much more complicated programs. Like what is the sum of all the digits? That's a good question. What is the sum of all the digits? So that one I like. How about this one? Write a method that takes in an integer n and prints out all the proper factors, all the factors of n aside from n. So in other words, what you can divide, all the things that's divisible by. So given a number n, print out all the numbers it's divisible by. I believe this one is another exam question that I've used before. The proper factors of n. So print out all the proper factors of n. So this one I don't actually have to return anything. It's a void method since I'm just printing out. So for int I is equal to 0, start from 1. I is less than n because we don't want to include n as a proper factor of it. N is not a proper factor of n. Here we're going to check all the numbers from 1 up to, but not including n. And we're going to check to see if n is divisible by all those numbers. How do I do that? I wrote a for loop over here to go all the numbers 1 through n. So I represents each number. So if I mod, so actually if n mod I, if n is divisible by I, system.out.print, and I'm actually not going to care that they're all going to be on different lines because it's an exam and time is money. Print out the ith number. So if I can divide it, so if n can be divided by I print it out. What other problems do I have on here? Write a method that prints out the first n Fibonacci numbers. I like this one. All right, so first of all, we got to ask the question of what the heck is a Fibonacci number, right? It's like, so fortunately, thanks to the Da Vinci Code and Dan Brown, it is actually much more well known than it has used to be. Anybody want to start me out with the first 2 numbers of the Fibonacci sequence? 1 and 1. Okay. So for those of you who have not seen this before, let's see if you can figure out what it is. So what's the next number of the Fibonacci sequence? 2. And the next one? What's the next one? Next one? 13, 21, 24. So you're following along and trying to figure it out. Actually not a particularly hard sequence. But it does sound like people are shouting rather random numbers that are always going up. What it is that it's actually a ridiculously easy sequence. Each number we have to seed it. We have to start it off first. For each number, after the first two is the sum of the previous two numbers. So 1 and 1 is, so 2 is 1 plus 1, 3 is 1 plus 2, 5 is 2 plus 3, 8 is 3 plus 5, 13 is 5 plus 8. So there's this whole idea of like how it grows and it corresponds to the golden ratio and stuff like that. But honestly, it's just a fun sequence because for math problems, it's nice, and it's an interesting question of how in the world do I actually write a program that generates Fibonacci numbers? How can I do this? I'm just wanting to print out the each Fibonacci number as we go along, right? So the way we write this is that if we were writing an equation that was recursive, we would say that the nth Fibonacci number is equal to the fib of n minus 1 plus the fib of n minus 2, which, as you'll learn in 2168, or if we get into recursion, we'll learn that actually this is kind of a terrible way to do this if we directly program that in. But we don't know enough to do it the wrong way. So I guess the only way to do it is to figure out how to do it the right way. So we're going to print out these numbers. And the key to generating this Fibonacci sequence is to realize that we only actually have to store 3 numbers at any given time. 2, really. Okay. The idea here is that basically we've got 1 and 1. Okay, and we can use that to generate 2. Okay, and now once we've got 1 and 2, we've got 1 and 1 and 2 generated. Okay, once we've got once we've got that generated, and we printed out 2, we can actually throw away this 1, right? And then we can use 1 and 2 to generate 3, and then we can throw away the 1, and then we can generate 5 and throw away the 2, then generate 8 and throw away 3, and then 5, and then get 13 and throw away the 8, meaning that we only have to keep 2 variables at any single time. Is kind of the point I'm getting at. So let's go ahead and start writing that. Print public static void print fib. So I want to print the first n Fibonacci numbers. So for int I is equal to 0. Let's see. What do I need? So n minus 1 is equal to yeah, let's call it minus 1. So Fibonacci number minus 1, right? The nth minus 1 Fibonacci number, int minus 2. And then int new fib is equal to, and then we'll just create a new fib over here, a variable to hold the new Fibonacci number. Okay. For int I is equal to, so these are the first 2 Fibonacci numbers. Okay. So let's go ahead and start at I is equal to 2 up to, but not including n, I plus plus. And then we need to do, so then we just do system.out.println. We want to print out, well, we want to use this to print out the new Fibonacci number, right? So generate our new fib. New fib is equal to 1 plus 1. So it's equal to minus 1 plus minus 2, right? Okay. So now we've got to actually now do that whole throwing away of stuff. And what we can do is that we can go and say, well, the previous minus 2, minus 2 is equal to minus 1, and then minus 1 is equal to new fib. Essentially, we throw out all the previous, we basically like shift everything over, right? The previous minus 1, the nth minus 1 Fibonacci number now is the nth minus 2 Fibonacci number, and the nth Fibonacci number is now the nth minus 1 Fibonacci number. So by doing that, we're able to shift this over with 3 variables, and minus 1, minus 2, and now system.out.println fib of 50, or it was print fib. And then we're actually going to use this in the last 10 minutes of class to solve an even tougher problem, which I'll bring up on the board in a second. System.out.println. Oh, right, I don't need to print anything out because it's a print. And there, it printed out the first Fibonacci, the bunch of the Fibonacci numbers, right? And then went up, and then it got here, and then it printed out a negative number, then printed out a positive. What's going on there? Why is it going positive, negative? Why is it going positive, negative, people? Sorry? It went above the maximum size for an integer. So obviously the solution is to do a bunch of longs here if I want to fix that, or to switch this to long. All right, with that, why don't we look at another problem? Project Euler problem 2. So they start the Fibonacci with 1 and 2. So I start with 1 and 1. That's fine. Doesn't really matter. But they give you the Fibonacci term, the numbers. By considering the terms of the Fibonacci sequence, whose values do not exceed 4 million, find the sum of the even-valued terms. So in other words, it wants the sum of all the even-valued Fibonacci numbers that are less than 4 million. Okay? So let's go ahead and modify our method. Euler 2. Doesn't need to take in an argument anymore. And what it's going to do is that it is going to run until we get basically, so now, and this can change our condition. We don't need a for loop anymore. It's simply while, let's see, let's go and say minus 1 is less than 4 million. Okay. So this will print out all the terms that are less than 4 million. Okay. And now really all I want is my objective is to sum up all the even terms less than 4 million. So now let's only print it out if it's even, if new fib is even. New fib mod 2 is even. Right, it's because the problem was the sum of all the even Fibonacci numbers less than 4 million. So now there's all the even Fibonacci numbers over here. Well, minus those ones. Boom. Okay, so we've got 2, 8, 34, 144. So all those numbers need to be summed together. So long sum is equal to 0. Then we add in the sum over here. Sum plus equals 0. Sum plus equals, well, not 0. The new fib number. Then system.out.println and run. So it's about 4,600,000 and 3732. Is that right? Let's go ahead and see. 3, 7, 5, 8, 4. Yes, it is. And once you get an answer to a problem, so the nice thing about Project Builder is once you answer it, you get access to a overview for the problem, which gives you like some insights that you may not have noticed about how to solve the problem. That basically, it turns out that every even term, it's odd, odd, even, odd, odd, even, odd, odd, even for the Fibonacci sequence. So you can do it that way. But also that you get to go to the problem. You got to go to the forum, and then people show how they did it in like assembly, or how they did it in C, or a little Visual Basic over there. I mean, that's from back in these are answers from 2004. These problems have been up for a while. So have these threads. So let's see what more recent people have done. So there's another C solution. JavaScript and Python. So you can see what basically people have come up with. Because these are very good So here's somebody's Java solution. So it's a very good way to do that. All right. So that's it for your review on the practice exam. I will upload this today in case you need to review it for Friday. Now, the other thing to note is that some of you might get sick or might be feeling sick. Do not come to the exam if you are sick. Instead, send me an email and say that you need to make up the exam. Do not come to the exam if you are sick. You will probably not do very well on the exam if you are trying to recover from an illness. And also, you're going to get everybody else sick, which sucks. Okay? So, that being said, please try, be honest. Don't simply say you are sick just because you're not ready to take the exam. You've got plenty of time to try it. Remember, there's a peer tutoring center. Come to my office hours if you have any questions. All right, so that's it.